Hello everyone. This session is about brief understanding of rollout in Kubernetes. Before even we start, keep that in mind that a rollout concept is actually applicable to the Kubernetes controller resources like deployment set, stateful set, daemon set, and replica set. It doesn't belong to managing any other resources. Okay, so by definition, rollout is actually a process of updating or deploying some new changes to an application which is already running inside the pod by ensuring that a very minimal disruption to the application's availability. Okay, so what we do now is let's directly jump to the practical session. Okay, and for any practical session, right, if you don't have a cluster available, far better is to use Killer Coda. Killer Coda, if you type, you will see this website. They give 1 hour session free for everyone at every refresh. Yeah, if you are specifically practicing any certificate, you can go for that environment, or you can go with directly like Playground. Okay, and here you can choose any platform actually. Okay, Kubernetes Playground, I will choose one node with 2 GB. They will give you. This is good for practicing. Now you can see I got this playground. I don't need to pay anything. They like you can see here timer also. 60 seconds they will give free where cluster everything is installed. You can start practicing. Okay. So what we do now, I have a deployment file. What you need to do is you need to do this start here. So I have a deployment file. You can find that file in my GitHub link, which I have given in the description here. What I have a deployment file created, and to showcase the rollout process, I have also given a some readiness probe here so that I will wait for 15 seconds for a pod to come up so that I can, like, since I have a 3 replicas, so one by one I don't want all the pod to come up very quickly, so I have given some delay by using some readiness probe. Yeah, in further sessions we can even talk about the readiness probe also. So I will start explaining you with a practical example. Okay, let's start this session. Now let's create a deployment file here. Deploy.yaml. Okay. So what we do, you can open multiple tab also here. One tab I will open for deployment and one tab we monitor something else. And every time you don't need to type kubectl here. There is an alias available already. So you can just type cube. So what I do, I will deploy this file. First of all, do we have any pod running already? We have no pod. Okay, apply -f, deploy this file. Okay, so once we deploy this file, okay, okay, get pod -f. You can see the pods are started. This is the initial deployment. Okay, so let the pod, all the pod comes up, and we can keep checking the rollout status also here. Okay, deployment. I have only one deployment here. 0 of 3 updated replicas are available. This is how you can check the rollout status. But I will better explain you the rollout once all the pod comes up. You can see here now all pods are up now. Okay, so all pods are up. What we do now? Okay, what we do now is we will update the image. We'll open the same deployment file once. Okay. Currently, it is running with BusyBox, some latest version. Okay, I will give a BusyBox. Let it take some different version of the image. Okay, what we do? K apply, not apply. It's a replace now. K apply, replace -f, deploy. Okay, done that, and KWS -p pod. One thing what you can see here, like all 3 pods are as is. Okay, they are not got deleted. What Kubernetes did is Kubernetes created a new pod. Okay, new pod, and new pod is not completely ready now. Okay, we can also check the rollout status. See, one is finished. It is telling. You can see here what it did. all three pods were as is. It created a new pod. Pod was waiting for 15 seconds, which I have added delay until the new pod ending with 2GG is completely ready. It didn't terminate any of these existing pod. Okay. Then once you can see, once this new pod comes into 1 cross 1 state, then it terminated the one of the older pod like 92 DM. Okay, it terminated this pod. So that's how, like, it will not terminate the pod until a new pod is completely up and ready and running. Similarly, it happened with the other pod also. Once that is done, you can see here it started. You can see here it started a terminating the new pod, and again it created a LNS ending with LNS, a new pod again. Once this pod came up, it might have, like, we didn't track that the status completely here. It terminated the 4.8, then it terminated the 3.2. So what it will do exactly is, where first it updates one pod. Okay, what it will create a new pod. Okay, once that pod is completely up and running, then it bring down the existing pod. Okay, then it creates a another new pod, and once that pod is come up successfully, it brings down the second pod. Hence it completes the rolling update following the same process. So what will happen because of this strategy, we always have three pod. If this deployment is having three replica, right, so we always have three pods always up and running. And that's how the rollout status also we can check. kubectl rollout status, for example, it started with 0 of 3 update replicas are available. Rollout to finish 2 means still 2 are left, then 1 is left. So all this status also we can check by using this command like kubectl rollout status and deployment. And if you have multiple deployment, you can give the deployment file name as well here. So that's the brief in this video. Okay, we'll create another video. Another video where we go depth into several rollout mechanism. What I have shown you is actually a default rollout mechanism where it always keeps three instance running, and it creates a new instance once that pod is up and running. Then only it terminates its one of the older pod. Okay, and we can check the current strategy also. If we describe the pod, we describe pod. If you see here, we have the strategy here. Something I will get a strategy. Rollout. Control by, wait. Sorry, not pod. Describe deployment. When you describe the deployment, you can see here strategy types rolling update. So whatever the strategy we saw, right, where it always ensures the three pods are running and always bring up a new pod. Once that pod is comes up into the running state, then only it will terminate the previous pod. So that is actually a rolling strategy. Let us quickly try once again. Last time we missed monitoring a little bit. So what we do, we again give a different image here. Okay, let us replace the pod. Okay, replace deployment. Okay, okay, get pod minus w. You can see here these were the existing pods. They were already into running state, and the Kubernetes brought up a new pod here. Okay, and we are waiting for that pod to be running state before we terminate any other pod. Let us just wait for 10. Now you can see this CZP pod is running. Since this pod is in running state, it is started terminating one of the older pod. It is started terminating one of the older pod. So one pod update is done. Now what it does, it created a new pod. You can see this name FXR ending with, it was not exist before. So this was the new pod, and that pod came into running state now. Then it is terminating one of the older pod here, 79H. Okay, it is terminating the older pod, and it spawned a new pod now again, that is ending with 27. You can see nowhere we have a pod ending with 27. Created a new pod, and that's how this error will debug again. So that's how this rolling update mechanism is working. This is the default rolling update. What I'm seeing the number 2 here, rolling update. This is what that strategy. Then we have several other mechanism of rolling update like recreate mechanism, blue-green deployment, canary deployment, A/B testing rollout, and all these things we will talk in detail in our upcoming videos. And we also have a rollback mechanism. Let's say you have updated an image and somehow you found like that image is not good, and if you want to revert back, there is an easy way where you can revert back to previous state as well. Actually, this rolling update, right, it also maintains state. For example, here in history, if you give rollout instead of status, if you go rollout history, you can see we gave two times, right? One is the revision 2, one is the revision 3. Okay, so that's how it maintains the revision. You can go back to this revision also, the how we go back to the previous revision, and how many types of rollbacking mechanism we have. All those things we will talk definitely in our upcoming videos. Okay, so that's all for today. Thank you. If you have any question, you can post it in my comment.